So welcome back to section 1.3, organizing categorical data. Displaying and organizing data is a constant theme throughout this class, and it's important to identify the type of data that you'll be working with. Today, we are going to be focusing on our attention on methods of displaying two categorical variables. And we want to be able to display them in such a way that we're able to identify patterns. Ultimately, our goal would be to know whether the two categorical variables are associated or related. So the table below contains a subset of data from the 2011 Youth Behavior Risk Survey. This survey was a national study that asked American youths between the ages of 14 and 17 whether they wear a seatbelt while driving or riding in a car. The people who said always or almost always were put together in the always group. The people who said sometimes or rarely were put together in the not always group. And the following table displays the data collected. So notice that this table has not been coded, but the one that's in your textbook was coded. If this table had been coded, for example, the variable gender would have been labeled male, and the males would have been denoted with ones for the coding, and the females would have a 0 for the coding. So what are our observational units? And our observational units are the youth ages 14 to 17. And what variables are of interest in this study? There's two variables, gender and seatbelt use. And both of these we can notice are binary in this study. So one way we have to organize our data is in a two-way table. Two-way tables can be used to summarize the data from two potentially related categorical variables. And so it's for two variables, and that's where the two-way part of two-way tables comes from. These tables show how many times each combination of categories occurs in the data set. The table does not display the actual data, but instead shows frequencies for combinations. So this is really just a summary of the data. And sometimes you may see it called as a contingency table. Some books refer to it that way. So on the next page in our packet, we're going to answer some questions about this two-way table. How many males are in the sample? So to determine the number of males, we are going to look at this column here with males, and we total it to find out that we have 5. How many females? We can total our female column to tell us that we had a total of 10 females. How many people do not always wear a seatbelt? That total we can get from our first row. So that is 5. And how many always wear a seatbelt would be 10. So do more males or females not always wear a seatbelt? So the number of females that do not always wear a seatbelt we can see up here in this square. That's the females that do not always, that's 3. And males that do not always wear a seatbelt, we can see here is 2. So more females do not always wear a seatbelt. Now let's look at question D. Is the percentage of males who don't always wear a seatbelt greater or less than the percentage of females who don't always wear a seatbelt? So the question is asking us to calculate a percentage of males. That's telling me what my denominator is going to be for my fraction. So we're looking at males. The total number of males is 5. And we want to know what percent don't always wear a seatbelt, which we said is 2. So this is equal to 40%. And then if we look at females, again, we're looking the percentage of females who don't always wear a seatbelt. So our denominator will be 10, total number of females, and 3 don't always wear one. So we get 30%. So even though in C, we saw that more females don't always wear a seatbelt, when we calculated the percent, more males, the percentage was greater for males who did not always wear seatbelts. So is it better to compare the number of numbers or frequencies, or is it better to use percentages when answering questions like, are the males in the sample more likely than females in this sample to take a risk of not wearing a seatbelt? And generally, percentages are better. So in order for us to compare the counts between 2 or more groups, the groups need to be similar in size, but that rarely happens. And so generally using percentages are often better for comparisons because they take into possible differences among the sizes of different groups. So if you were just to compare counts, that information can often be misleading.